So today's video is about testing a claim about P, which is the population parameter for proportions. And I'm going to take a look at significance tests for proportions, as well as encourage you to look at the technology toolbox on page 772 to know how to do a one proportion z-test using your calculator. All right, so a couple quick reminders before we really get started. The sampling distribution of our sample proportions is approximately normal with the following mean and standard deviation. Now notice these formulas are on your formula sheet, so no need to memorize them. Now when we do a confidence interval, remember that we don't have our population parameter P. So what we have to do is we have to substitute our P hat, our sample proportion, in the standard deviation to obtain the standard error. So this is how we came up with our one proportion z interval formula. Now this is what we did back in chapter 10. Now for significance tests, it's slightly different because we start with a hypothesized value. We start by believing that mu of p hat is equal to some value which we will call p naught. Now we assume that this value is correct when performing our calculations. Let me say that again. We assume that this value, P naught, is correct when performing our calculations. The only point that we can be proven wrong is when we get to our calculations portion. That means with our hypothesis and our conditions, we are assuming P naught is correct. If we standardize P hat, our sample proportion, by subtracting its hypothesized value and dividing by its standard deviation, we obtain our z statistic. Now remember, with one proportion z intervals, we will always do z intervals or z tests for proportions. That's why this is called a one proportion z test. Now here's an example. There was a study about job stress posing a major threat on the health of workers. A national survey of restaurant employees found that 75% said that work stress has a negative impact on their personal lives. We took a random sample of 100 employees from a large restaurant chain, and we found that 68 answered yes when asked the question, does work stress have a negative impact on your personal life? The question is this good reason to think that the proportion of all employees in the chain who would say yes differs from the national proportion of 75%? Now notice the key word in the sentence is differs, so that's going to help us with our hypotheses. Step 1, we need to identify our population and parameter. In this case, we want to estimate or test about our true population proportion P, the true proportion of the chain's employees who would say that work stress has a negative impact on their lives. Notice my population in this case is all of the chain's employees. Now my null hypothesis is that the proportion is equal to 0.75. My alternative though, since it was a differs then statement, is going to be a two-sided not equals. Now they don't tell me to use any specific significance level, so in this case I can choose my own. I'm going to choose 10%. Step 2, my conditions. We're going to do a one proportion z test if the conditions are met. Now, we're told they took a random sample, however, we do not know for sure that it was an SRS. So it's important to make note that a random sample is good, but we still need to be careful and proceed with caution. Normality, I'm going to check my NP, n times 1 minus p condition. Remember, the central limit theorem does not apply to proportions. Now, it's important to notice here, we are using our hypothesized value of P because we haven't proven it wrong yet. We would not be plugging in our sample proportion. Okay, we're going to use our 0.75 because we believe that that is true until I'm proven wrong. Independence, sampling without replacement, so it makes sense that I need to have at least 1,000 employees. It's reasonable that this chain restaurant has that many, therefore I can assume independence of my subjects. Finally, I get to my calculations. Now my test statistic in this case is going to be found by taking my sample proportion minus my hypothesized value over the standard deviation. Now notice, once again, I have not proven my null hypothesis value of 0.75 incorrect yet. Therefore, Notice that I'm plugging in 0.75 in my standard deviation. Common mistake that people make is plugging in their sample proportion, when at this point I have not proven it incorrect yet. So I get a test statistic, a z-statistic, of negative 1.65, which falls right about here on my distribution. Now, from table A, when I look up that z-score, I get an area to the left of 0.0526. Now, this was a two-sided test, which is why I'm going to double this p-value. So I end up with a final p-value of 10.52%. Now that takes me to my interpretation. I must fail to reject my null hypothesis since my p-value of 10.52% is greater than my significance level of 10%. In context, that means, therefore, I have sufficient evidence to suggest that the proportion of this chain's restaurant's employees who suffer from work stress is different from the national survey. And I apologize, that should actually say is not different from the national survey. Now, a couple things just to point out real fast. If the sample of restaurant workers is sufficiently large, we will have sufficient power. Remember, sample size is one of the ways to increase power. If our sample size is very, very small, we may have a difficult time detecting differences that could be important in this case. Once again, remember, sample size is one way to increase power. Now, to kind of wrap this up, I just want to bring confidence intervals back into the equation. What do confidence intervals tell us that a significance test doesn't? Right? So what do confidence intervals tell us that a significance test doesn't? Well, let's remember, the purpose of a confidence interval is to estimate the population parameter. So while a significance test tells us whether or not our hypothesized value is correct or not, an interval actually will estimate the value of a population parameter. So to see what other values of p are compatible with the sample results, for example, in this case, we had 68 out of 100 that agreed work stress had a negative effect on their personal lives. Now in this case, notice when I checked my conditions for a confidence interval, I do not start with a hypothesized value of p. Therefore, in my conditions of a confidence interval, I would in fact use p hat. So this says, find the 95% confidence interval for the true proportion of employees who feel that work stress had a negative impact on their lives. So in this calculation, once again, remember that I would be using my p hat and my standard deviation because a confidence interval does not begin with a hypothesized value. Therefore, I do not have a p to plug into my standard deviation. So in this case, my sample was 0.68 plus or minus 1.96 times my standard error, and sure enough, I get an interval of 0.59 to 0.77. Therefore, I'm 95% confident that between 59% and 75% of the restaurant chain's employees feel that work stress is damaging their personal lives. Notice my hypothesized value of 75% falls in there, so that could in fact be the correct proportion. Now I made this little table. This is not in your textbook, so if you'd like to jot it down, I would encourage you to freeze the video right now and do so. But it kind of breaks up the proportion z interval versus a 1 proportion z test and the similarities and differences. So once again, with an interval, when I'm checking my conditions, I do not have a hypothesized value of p. Therefore, I have to plug in p hat. Also, when I'm calculating my interval, I do not have a hypothesized value of p, so notice in my standard deviation formula, I use p hat. However, if we come over to our 1 proportion z test side, I begin with a believed value of p, which is why I use that throughout all of my calculations, including checking my conditions, as well as in my standard deviation formula denominator. All right, I hope that helped with 1 proportion z tests and intervals. This would be your assignment for tomorrow night on this topic. Once again, I encourage you to work through the technology toolbox of how to do a 1 proportion z test. And don't forget, we have our chapter 12 test coming up.